All right, let's get started. So this is our VLAN, inter-VLAN routing, multi-layer switches lab. Wow, this looks confusing, doesn't it? But it isn't. It really isn't. You know, it's all about two things, Ethernet and IP. And we throw some VLANs in there just to segment those broadcast domains. We also are adding something called a multi-layer switch or a layer 3 switch, which is nothing more than a device that looks like an Ethernet switch, but can also do routing. So let's get started. So in this network here, we have our network, which is the 10.0.0.0/8. That's the private IP addressing space we are using. We have our edge router right here. This is edge router here is connected to our ISP. Okay? And really what we're concerned about is everything below this edge router. Now, first of all, I've already configured everything on the right side over here. Okay, so it's working. But what we're looking at here is, let's say our organization has just added a new building. Okay, and with some new users, and here's the building right here, the devices in that building. Okay, we have a new multi-layer switch connected to another multi-layer switch core, and this one here, multi-layer switch 2, MLS 2. We'll talk about those later, but let's just start right from the beginning. Let's make this real easy. Yep. So what we're going to be doing here is just configuring these 3 new switches, this multi-layer switch and these 2 layer 2 switches, access switches. And we'll be modifying this other multi-layer switch here, core 1. Some other things to make note of, and we'll refer to this in a little bit here, but we are running OSPF in this network here. This part of our network here is layer 3 only. So you can see these are individual IP networks. Okay, these are multi-layer switches. This is a router. We'll talk about that in a moment. But for now, let's get started. So what I'm going to do is go over here to access 1A. Okay, now on these switches, our IT department has already configured a few things for us. So I'm going to do enable. Class is the enable secret password, but they've done a few things for us. For example, let me just show you here real quick. Okay, what do we have here? Just already host name. Okay, enable secret class, no IP domain lookup. What else do we have? Line console 0, logging synchronous, and just for lab purposes only, exec timeout 00. All right, so one of the things that we need to do is we need to add some VLANs. We got a few VLANs here we're going to add, so let me get started. Okay, so I'm actually going to add the VLANs along with some names. So I'm going to say VLAN 10. I'm going to name that engineering. Okay. This is going to be our engineering group in VLAN 10, the blue VLAN down here. They're actually part of the 10.10.0.0/16 network. You can see these VLANs up here. Okay, so they'll get an address within that network range. We're also going to create VLAN 20. This is going to be our sales team. Okay, and our sales team will get, you can see them in the kind of this reddish pink color here. They'll be in the 10.20.0.0/16 network. Okay. Now over on the other side here, we have VLAN 30, human resources, in the 10.30.0.0/16 network. And in this, I don't know, this deep red color, I guess, VLAN 40, that's another part of engineering. So engineering is actually in 2 different buildings. You can think of this as another building in our scenario, but they're in the 10.40.0.0/16 network. 2 different networks, 2 different VLANs, that's fine. We also have another VLAN over here, VLAN 77, which is for our server, internal servers. In this case, we have a DHCP server. Oh, I'll talk about that a little later. We also have two management VLANs, VLAN 90, which will be our management VLAN for these devices. And then another one that we're not going to worry about, but it's already been pre-configured, VLAN 91, which is the management VLAN for these devices. We also have a native VLAN 998 and a parking lot VLAN 999. All right, so let's get started on a little bit more of this. We've done our two user VLANs. And just to have all of our VLANs already pre-named, I'm going to do VLAN, you know what I'm going to do. Let me do VLAN 30. I was just going to copy and paste, but I'll type these out. VLAN 30, okay, this will be named HR. VLAN 40, which will be also engineering. Same name here. And I'll put, I don't know, I'll put engineering. I'll just put engineering. You know, two names. Oh, engineering 2. Okay, there we go. I could have two engineering VLANs, but I got to name them differently. All right, but to show that they're both part of engineering. What else? I said VLAN 77, which will be our internal servers. I'll just put servers. And VLAN 90, which is our management VLAN. Management 1. I got to say name, don't I? And VLAN 91, which is our management 2 VLAN. I didn't put name there. Should know that. I should know that maybe. All right. Now, is it important to have all these VLANs, even if they're not over here, like VLAN 30, VLAN 40, VLAN 91, VLAN 77 only exist over here? No, but just going to add them on. Maybe we're going to add, yeah, so we'll just put them so we can have all the names everywhere. All right, next, let's do this. I'm going to do exit here. And what I am going to do for security reasons, configure all the switch ports with the following. Okay, so I'm going to configure all the switch ports on this switch here, which is interface range, these fast Ethernet and these gigabit ports. First of all, I'm going to shut down all the ports. I'm going to get a whole bunch of shutdown messages here. Okay, so they're all been shut down. I'm going to put them all in switch port mode access. So by default, all my ports will be access mode, not trunk. And by default, I'm going to put them all in the parking lot VLAN, which is 999. Okay. Oh, why didn't it say, oh, I didn't create that one, did I? Did I miss that one? Oh, yeah. Oh, I didn't add all of them. I didn't add all of them. I stopped at 90. Oh, Rick. Oh, that's okay. See, if I don't add the VLAN, it says I added it. It added it for me. But what I'm going to do is just so it has a name. You say name parking lot. And I didn't also do VLAN 998, which is our native VLAN. Okay. All right. If I do show VLAN, by the way, show VLAN brief. Let's make this little. Notice that everything, where is it? It's all in the parking lot VLAN. All of our ports. Okay. That's where they are right now. That's what we want. Okay. Okay. So, you know what's happened is one of the engineers we have over here in this building here, they have an office that is connected to a port in their office that we have connected from in our wiring closet. We have connected their port to their patch panel port. Let me kind of show you what this looks like. This here would be an example of the user's computer connected to a modular wall jack in their office. This would have a number on it. Okay. Then at the other, somewhere in our wiring closet or data center, where this cable ends up is the back of a patch panel. That will have a number on it. This number will be associated with this number. So we know who we're patching in. And what we're doing is we're going to then take a cable and take it from that port into our switch port. In this case, I'm going to patch them into our switch, access 1A switch on fast Ethernet 01. Okay, so it'd be one of the first ports, but that's what we're doing for taking their port and connecting them to specifically fast Ethernet 01. So what happens when we do that? Well, we got to enable the port for them. Okay, so what I'm going to do is config T. Of course, there's many other things I've got to configure the rest of this switch before it becomes active. But let's get started. I said I've put them, their modular wall jack is connected to a patch panel that we've patched into fast Ethernet 01 on this switch. See it right there? All right, so let's make it switch port mode access. Now that's what it is by default, but I'm putting it in anyway. Make sure it's an access port. Now, right now it's in the parking lot. Okay, parking lot. It's in the parking lot. Same thing as a parking lot. Okay, switch port. Hopefully your spelling is better than mine. Switch port, access, VLAN. They're in VLAN 10. Why? Because they're in engineering. They need their computer is going to get an address with 10.10.00/16 network, an IP address from that network from the DHCP server. We'll see how that works. Very cool. Okay. Now, another thing I'm going to do is something that perhaps we haven't talked about in some of my classes, but you will learn about this. Okay. Perhaps we've already talked about it, depending on what class is using this video. Spanning tree port fast. What this is going to do is, as soon as the user connects to the port, it's going to go into forwarding state. Okay. All right. Anyway, you see it has a little message here. Make sure that we are not connecting this port to a switch, that this is an end device. Okay, this ensures that DHCP messages are sent immediately from this device to the DHCP server without waiting for the normal spanning tree port state process, which takes upwards of 50 seconds. Okay, you'll learn about that later. But remember, we've also made this port is in shutdown mode. So let's do no shutdown. All right, so it's up. And notice, see this green link light here? When right here, FA01, that's because of this command here. Immediately went into forwarding state. All right, next, what do we got next? We have another user, sales department. So let's go there. Let's do that user. This user is in sales. Okay, so they're connected to a port that we have patched into fast Ethernet 013. So let's do that. Okay, so I'm going to interface fast Ethernet 013. Again, switch port mode access, although we've already done this. That's the default. Make sure, never hurts. Then I'm going to say switch port access VLAN 20. I am putting this user in VLAN 20, sales VLAN. They're going to get an IP address from the DHCP server from this network, the 10.20.00 network. Okay. I'm also going to make them spanning tree port fast. Okay, watch, as soon as I hit enter, that will go, oh, not as soon as I hit enter, but as soon as I do no shutdown, that port will immediately go green here on fast Ethernet 13. Again, got to make sure that this is not a switch here. Talk about this later if we haven't done so already. There we go. That port is now green. Okay, almost done, but we got a couple of things to do here on access 1A. Okay, so let me do exit here. One of the things we're going to do is now configure a switched virtual interface on access 1A to allow us to remotely access this switch so we can remotely manage it. Okay, so our management VLAN for this side of this part of our network is VLAN 90. Okay, and it's in the 1090.00/16 IP address space. So let's do that. Let's see, interface VLAN 90. This is how I create a logical virtual interface. Okay, I'm now going to give it an IP address 10.90.0.5, 255.255.0.0. Okay, so this is the IP address I will use if I need to SSH or telnet into the switch. SSH is always better. All right, so that looks good. Now I can, although it says change state to up, never hurts to do a no shutdown. Okay, all right. The other thing I need to do on this switch is, what if I want to remotely access it from another network? Okay, which typically is what I need to do. Okay, because my PCs are all on other networks. Okay, so I need to give this device a default gateway address. Just like your host has a default gateway address, the switch needs a default gateway so it can send packets outside its network, because remember, we're accessing it from another network. The packets are going through the router to the switch, and then the switch needs to send the packets back to us. Again, I'm talking about Telnet and SSH. Okay, just for remote management. 10.90.0.1. That's going to be its default gateway. Okay. Now, if you're wondering where that is, that's going to be our multi-layer switch here, acting as a router. See that 10.90.0.1? That's where it will be. Okay. Last but not least, we need to configure this trunk link here between us and the multi-layer switch. So let's do that. Exit. Oh, no, I think I'm in the right place. Yeah, global config mode. Okay, interface gigabit 0/1. This port right here with another switch. First thing I got to do, remember I put this in the parking lot VLAN. So I need to take it out of that VLAN. Okay, I say you're no longer in VLAN 9999. Okay, now I didn't do that for these other ports. Let me show you. Notice I didn't do that for these other ports because when I said switch port mode access VLAN 20, it overrode 999 with VLAN 20. But here I'm not making it an access VLAN. Here I'm going to make it a trunk link. So I have to remove that access VLAN specifically. So I'm going to say switch port non-negotiate. I'm going to let it. There we go. That disables dynamic trunking protocol. I don't like that. Let me do it the manual way. Switch port mode trunk. I am going to trunk. And I'll do the same thing on the other end. I'm also going to say switch port trunk. I'm going to set the native VLAN. Remember our native VLAN here? It's an unused VLAN. Okay, this is just for kind of legacy untagged frames. Okay, switch port trunk, native. How do you spell native? Native VLAN 998. Okay, I'm also going to say switch port trunk allowed VLAN, and the VLANs I'm going to allow on this. Now, by default, all VLANs are allowed, but just for good practice, I always put the space. Doesn't like spaces in this particular command. Okay, so VLAN 1 by default, that's all of our control traffic, CDP, DTP, VTP, all the Ps, STP, things like that. Here's our two user VLANs. This VLAN we really don't need. That's our server VLAN. This is VLAN 90, which is our management VLAN. And if I want to include all the, all of our room, I really don't need VLAN 91 since we're not doing anything with VLAN 91 traffic, but it's just really, the only VLANs we really need is 1, 10, and 20. Okay. And of course, our native VLAN, we have to, all right. Actually, we don't even need the native VLAN in the allowed list. We don't have any traffic going across it. The only traffic we really have going across this trunk link is 1, 10, and 20. All right. Let's do a no shutdown. Now, as soon as I do this, I'm going to get an error message because my native VLAN is 998. The other ones, well, actually, we won't get an error message because I haven't configured this other side of this trunk. But on MLS1, when we configure the trunk, we'll get we would get a error message if this was also not set at 998. Okay, well, let's press enter. Yeah, here we go. All right, gigabit change to up. See, it all depends on when this amber light's going through spanning tree. When it turns green, depending on what the dynamic trunking protocol, this is Cisco switches, if it is trying to trunk with me and does trunk, then we'll get an error message because our native VLANs are different. All right, we'll come back to that, see if that happens. Okay, that looks good. Okay, I think so. Okay, all right. Okay. Let's go to access 1B. Okay. Now on access 1B, going to do similar. Okay, let me do enable class. I can type class. There we go. Config T. All right. So one thing I'm going to do is I'm just going to copy these in. I'm going to do the same as I did before. Oops. I can use paste here. There's all my VLANs. Okay, just like we did before. All right, I think we're good there. Oh, I've got one that's wrong. Oh, I got to change that. Let me do that right now. I have 40 name exec. That's engineering 2. Okay, no problem. VLAN 40. And we'll change that to name engineering 2. It doesn't always help to copy and paste. Okay. And just do exit here. Next, what we're going to do is do our default. Okay, for all of our switch ports. Okay, we've got to put them all. Let's do this. Okay, I'm going to first shut them all down. Okay, I'm going to put them all in access mode. Okay, then I'm going to put them all in the parking lot VLAN. Okay, all right. I can actually just do show VLAN. To do the do in front of it, I don't have to go back. I don't have to exit out. Isn't that clever? Okay, but you see they're all in the parking lot VLAN. Okay, similar to before, we have a engineering user that's also going to be on port fast Ethernet 01, but on access 1B switch, we patched them into that physically. So we need to configure that port. And then we need to configure on access 1B, the switch we're on, fast Ethernet 013 port, because we've patched a sales department user into that port, and they need to be on that network. So they'll be on 2 separate networks. They'll get addresses from 2 separate networks. For addresses for their specific networks, maybe I should say 10.10.0.0 for engineering, 10.20.0.0 for sales. Let's get this done. Okay, so let me go interface gigabit FA01, switch port mode access, although it's already that. Okay, switch port access VLAN 10, that overrides the parking lot 999, spanning tree port fast. Yes, we know that. Don't put a switch there. Make sure this is not a switch. And then we'll do no shutdown. Okay, let's do exit. Let's do similar for interface FA013. The switch port mode access, which is, it is already, and switch port access VLAN 20, because this is sales. Okay, this is the sales. Okay, and then spanning tree port fast. Okay, and then no shutdown. Okay. Matter of fact, if I do show VLAN, you will see that FA01 is on VLAN 10, sales is on VLAN 20, everybody else is still in the parking lot. All right, let's go ahead and configure the SVI. Okay. Let's go ahead and do config T, interface VLAN 90, same management VLAN. Okay, 90. But this switch, now this again, to remotely manage the switch. IP address 10.90.0. This switch is .5. We'll make this one .6. This is when it acts almost like a host. So we can telnet into it. No shutdown. Okay, let's actually, and we also have to give it the default gateway 10.90.0.1, which will be like this switch here. This switch will use MLS 1 as its default gateway, which will also be acting as a router. Okay, almost there. Let's do config T, since I exited out. Interface gigabit 01. We're doing the trunk now. I'm going to do this trunk link. Okay, so because we're going to be configuring it as a trunk link, let me first remove move it from being in the parking lot VLAN. Okay, next, switch port, non-negotiate, remove dynamic trunking protocol, manually configure it as a trunk. Okay. Then now we're going to say the native VLAN is 998, which we'll configure on the other side of this trunk. And then we'll do the same thing, the allowed VLANs. Switch port, trunk allowed, VLAN 1, 10, 20. I don't really need 77. I do need 90. That's our management VLAN. And I really don't need that worry about the native VLAN since we don't send any traffic across it, but there it is. Okay, I'm going to do no shutdown. Okay. A few things to look at here real quick. Let's do show IP interface brief. Okay, here's our VLAN 90. That's the IP address associated with this switch to remotely access it. We can see our gigabit 01, okay, is up and up. Fast Ethernet 13, fast Ethernet 1. Okay, we took a look at show VLAN already, but let's take another look at that. Okay, there's our engineering and sales access. Everybody else is in parking lot. If I do show interfaces trunk, okay, right now it says its trunking mode is on, 802.1q, that's the trunking protocol. This is the VLANs allowed across this trunk. Okay, and our native VLAN is 998. Now we haven't configured the other side yet. Okay, we're almost there. Now let's do MLS 1. Okay. There we go. See, we're getting a bunch of errors here. Okay. All right. Yeah, that's because we've done some configuration on these switches, but haven't configured these two links here. Okay. All right. Class is the password. I'm going to do the same thing as far as just copying the VLANs. Okay. And I probably made that same mistake. Yes, I did. VLAN 40 is actually a name, engineering 2. There we go. All right. So there's our VLANs. Okay, right now, show VLAN. Of course, everything, as we know by default, is in VLAN 1. Okay, we're going to change that now. Okay, but there's all of our names for our VLANs. Okay, even those that aren't necessarily on this part of our network. All right, let's do the same thing. I'll try and do this as quickly as I can here. Config T. Okay, there's the range. What we're going to do, same thing. Shut down. Switch port mode access. This is the default for everything. Switch port access VLAN 999. Okay, exit. Okay, by default, everything is shut down. If I do show VLAN, okay, you can see everything's now been moved to the parking lot. And by the way, if I do show IP interface brief, there's different ways to do this, but you notice that they are all administratively down. Administratively down means shut down. All right, let's create now. All right, what should we do next? Well, I think we should do it in the order that Rick has it in the lab. Okay, next thing I'm going to do is create some switched virtual interfaces on this switch. This is a multi-layer switch. Okay, so what I'm going to do is I'm in global configuration mode, interface VLAN 10. Okay, now this interface VLAN 10, this is this SVI right here, 10.10.0.1. This is the default gateway that's going to be used by devices in VLAN 10. This is going to be their router's IP address. And here it is right here, interface VLAN 10. We say IP address 10.10.0.1.255. That's the IP address. Notice this IP address here, that's the default gateway for any devices on VLAN 10 or any devices on this that are in the 10.10.0.0 network. Okay, I'm going to do a no shutdown. I'm also going to do the same thing for VLAN 20. Okay, VLAN 20. Okay, and I'm going to give it the IP address. I'm going to cheat here a little bit, 20.1. Okay, so this is the default gateway for any devices that are, let me say this kind of a different way here. What we are doing is we're creating an IP address that's associated with VLAN 20. Any devices in VLAN 20, which will have the same network, belong to the same network, in this case 10.20.0.0. This will be their default gateway address. We're going to be making this multi-layer switch, layer 3 switch. It's going to be also a router. Okay, so these are the default gateways. Now, if you remember, I also created a management VLAN and IP addresses on the 2 switches. Okay, so let's go ahead and create the interface VLAN 90 IP address. Okay. IP 10 dot, what do I have that? 90.0.1, 255.255.0.0. That's going to be, that's the IP address used by the switches when we remotely access it from another network and needs to send the packets back out to the client accessing it remotely. This will be its default gateway as well. Oh, I forgot to put address in front of it. You can always see, it always helps us. See this little caret here? That means it doesn't, it's not expecting this. I was expecting this. Okay, let's do no shutdown. Okay. Okay, we're almost there. All we have to do now, as far as this part of the network, is configure these trunk links just like we did, same parameters as we did on access 1A and access 1B. So what I'm going to do is say interface gigabit 101. Notice I have it all labeled here. I'm showing you the labels. Okay, same parameters. Okay, so actually I'm just going to copy. Okay. All right, so you can see the parameters here. Take it out of the parking lot, non-negotiate, switch port mode trunk, native VLAN 998. There's our allowed VLANs and no shutdown. Okay, you can see things are changing up now. Let's do the same thing here for this other port, gig 102, a trunk link here. Interface gigabit 102. Okay, and I'm going to paste the same commands. Okay. See some green link lights on this side. This side is still running spanning tree. Take a look at some things here. Let's do this. Show VLAN, right? Okay. Right now, this is this switch right here. Okay. Right now, everything's in parking lot except for two ports that are missing. Some ports missing. These two ports here. Let's do show interfaces trunk. By the way, you can shorten commands as long as it's unique. Okay, there we go. Running two trunk links, one with each of the access switches. All right, we're not done yet. Okay, got to do a couple more things here. One, just making sure I do this in the right order. Yeah. Okay. This link right here. This is a routed port, gigabit 103. We're going to take that physical port and make it just that port. We're going to give it an IP address on this network that it shares with Core. They both have, Core has it. We're going to give Core an IP address on this network too. Okay, so what I'm going to do is go into MLS1 and I'm going to say interface gigabit 103. Now, by default on this model multi-layer switch, it defaults to a layer 2 normal Ethernet switch port. We're going to say no switch port. That makes it a layer 3 port. What can I do now? I can give it an IP address. IP address 10. I couldn't do that before that last command there, no switch port. You can try that. Try doing this first if you wish. And so I've given it an address just like I would on a router. Okay. So this is an IP address on this network. There's actually only two devices on this network here. MLS1, this port, and soon Core 1 on this switch port. Okay. I'm going to do no shutdown. Okay. All right. Now, by default, this router does not do routing. This multi-layer switch does not do routing. If I do show IP route, oh, it's actually showing, okay, that's interesting. This version of the iOS does show me the routing table. All right, so I am going to configure routing. Okay, so we're going to say IP routing. Let me check something here real quick. Show run. See the show, it's there by default. Okay, that's not true of all multi-layer switches. Some you actually have to configure the routing. Okay. But I'm going to have you do it. Okay. So IP routing. Okay. Without that, it would not have, unless it's there by default, you don't have a routing table. Also, what this allows us to do is configure static routes and dynamic routing protocols. Really, Rick? Yes. We're going to run we're running OSPF here. Okay. These are all routers here running OSPF. So let's have this device here, okay, tell about all of its networks that it knows about. Okay. What networks does it know about? Well, it's directly connected to these networks. Okay, all right, let's configure routing. Router, remember this, router OSPF1, router ID, here's our OSPF router ID. And what I'm going to do is give this network command 10.0.0.0.0. And I'm basically saying 0.255.255.255 area 0. That means any of my networks beginning with 10, enable them for OSPF. Okay, 10 anything. So any of my 10 subnets. Okay, let's do exit. We're almost done. I'm going to do something. I'm going to just show you these commands here. Let me just quickly do these, copy and paste them. I'm going to talk about this in a later video. See these commands here? Don't worry about these, but this is very cool. Okay, what this allows is this. Let me move this out of the way here a little bit. There we go. IP helper address 1077.77.77. That's the IP address of our DHCP server. Okay. Our DHCP server, by the way, oh, this is so cool. So I'm trying not to go over it in detail here. Okay. But our DHCP server has been configured with 4 DHCP pools. When it gets when this switch receives a DHCP discover message, a broadcast, hey, I need IP addressing. Who out there's a DHCP server? This switch receives it tagged on VLAN 10. So it says, oh, I have a device on VLAN 10 that's looking for a DHCP server. I am configured to help you out. So I'm going to use my VLAN 10 address, 10.10.0.1, and as the source IP address, and send and forward relay your DHCP discover message, relay it to this server. Again, I'm sending it from my 10.10.0.1 because I saw it come in on a VLAN 10, tagged as VLAN 10, and broadcasts don't go beyond me. So this is being sent as a unicast from me, 10.10.0.1, to the DHCP server. Here's our DHCP server. DHCP server looks in its pool and says, oh, 10.10.0.1. Yeah, let me give you an address starting with 10 from my pool. Maybe you're 10.10.0.100. Maybe that's what you'll get, or 101, 102, whatever it might be. Let me offer that along with me as your default, as this address is your default gateway. That's the address of our multi-layer switch 1 here. Okay, switch virtual interface VLAN 10, 10.10.0.1. So I'll give you that as your default gateway, your DNS server address, subnet mask. Okay, that gets relayed all the way back to MLS1. That then relays it back to this host. And that's how it's going to get a IP address for that specific subnet. And that's true for all of our different subnets. Isn't that cool? All right, we're almost done. We actually only have one more thing to do here. Core. Okay, because we have added this multi-layer switch here. So let's go into core. And what I have to do here, core is an interesting router. It's a multi-layer switch, say router, same thing. Okay. Show IP interface brief. Okay. It actually has has two IP addresses on two interfaces. Gigabit 0/24, which connects to edge up here. And it has this one here that it connects to MLS2. But let's give it an IP address here to connect to MLS1. Okay, so gig 101, this interface here, currently down. Let's go ahead and configure it. Config T. I'm going to say interface gigabit 101. I'm going to say no switch port by default. It's layer 2. Let's make it layer 3. An IP address 10.99.1.1. Is that right? Yeah, 10.99.1. This was 10.99.1.2. Will be 10.99.1.1. Okay, no shutdown. You're going to see a bunch of stuff starting to come up as soon as I do this. Okay, that link comes up. Okay, all right. We've really now done it all. But let's wait a moment here, wait for some things to converge, like OSPF here. So let's take a look at a few things here. Let me do show IP route. Okay, so it's learning about some networks here. It already knows about these networks here. Okay, but we're waiting for it to converge to learn about these networks here. Let me see, look, there we go. OSPF says, hey, I formed an adjacency. Okay, with MLS1. Now I bet you our routing table is going to show some additional networks. The networks advertised by MLS1, which is, what do you think? 20 and 30 or 10 and 20? Yep. Look at that, via MLS1. We're doing it. We're doing it. Okay, let's see what else we got going here. I know what I want to show you. I want to show you that Core 1 has already been configured for OSPF. I like to do the show running config just so you can see the configuration commands. And it was already configured with a similar network statement that we did on MLS1 that said anything in our 10 anything, doesn't matter what this part is. We have an interface, a VLAN that's part of this, we're routing for it. Okay, let's take a look at a few more things here. Maybe let's take a look here. All right, let's do, and how about show IP route? Can I spell IP? Look at this. Does it have all of our networks? There's our directly connected 10, 10, 10, 20. These are VLAN. See, it shows directly connected interface VLAN 10 and 20 because these are switch virtual interfaces that it has. And it's connecting with these network, any devices down here on the trunk link. So it's using the trunk, any port connected to VLAN 10 or 20 to connect to these, including the trunk. These networks here, 30 and 40 and 91, it's learned via Core 1, so that's coming from a physical interface. You can see that right here. Yeah. And oh yes, our core router is advertising a default route. Not our core router, our edge router. Let's take a look at that real quick. Our edge router is also running OSPF. Okay, there's our edge router. running OSPF. There's the network. Default information originate. It is advertising a default route. And it's going to send everything to the ISP. The ISP is, this address is 1111. I made it simple. Let's take a look at a few things. How about that? Is everything working? Let's take a look. Okay, let's start from the beginning here. Show VLAN. Okay. Yes, we have our access VLANs, a couple of devices on these two ports. Everybody else parking lot. Show interface trunk. Okay, yes, we are trunking with the multi-layer switch. Show IP interface brief. Okay. Yes, we are having this switch has an address which we've made a part of the management VLAN, and this is just for remote access. All right, let's take a quick look at our MLS. We saw the routing MLS1. Yes, we are routing. This is layer 3. Let's do show VLAN. Okay. Everything is in the parking lot. We don't have any users. We could. I could put users on these unused ports just like we do on a layer 2 switch. Matter of fact, if you take a look at MLS2, this port here, gigabit 1024, is a user port on VLAN 77. These are trunk links, and this is a routed port. So we can do it all. I know it seems confusing. I know there's a lot of different things. You know what? If you ever come into our lab, we can do this physically. We can do this physically, set it up. It makes even more sense. All right. I can do show interfaces trunk. Okay. Now the big test. Let's go to one of the PCs. That's PC 0 here, this one right here, our engineer. Okay, let's see, first of all, did it get an IP address for the right network? Yes, it did. This came from the DHCP server. It got an IP address, subnet mask, a default gateway. That was all relayed by MLS1. It's DHCP messages relayed back and forth. So it got the IP address on the right network. Now, why did it get it for the right network? 10.10.0.0, because we have associated this network 10.10.0.0 with VLAN 10. And on this switch here, MLS1, we configured switch virtual interface. We configured, let me do this. Go through all, I'm sorry to go through all of that there just to get to where I want to get to. We said interface VLAN 10 is a member of that network, 10.10.0.0 network. Okay. So when it relayed it from this address. It says the request came in tagged across this trunk link, the broadcast, the Ethernet broadcast, looking for a DHCP server, got tagged right here as VLAN 10. Untagged, but I knew came in tagged as VLAN 10. So when I send out the helper, hey, 10.77.7, I send it from me. And then it knows, hey, oh, somebody on the 10.10 network, let me give an address for the 10.10 network. And by the way, the show running config shows you for all these VLANs here, for all these specific IP addresses. This is also the default gateway, or will be, or is now, for this device here. Notice this is the MAC address. Let's take a look at that real quick. This is so cool. Okay, let's do this. Let's ping our default gateway, 10.0.1, our default gateway. Let's do ARP, look at the MAC address associated with that IP address. There it is right there. So yes, Cisco routers give a different MAC address for each switch virtual interface. Let's test a few other things. Can I ping? Let me get rid of that here. Let's try pinging maybe one of these. Let's see if we can ping the DHCP server. That's on another network, isn't it? Ping 10.77.77.77. Yes. Can I ping? Wow. Here's a switch virtual interface on this switch here, 10.91.0.5. Can I ping it? There we go. Why did it time out? ARP requests had to take place. Hey, if I can tell, so what if this is me? I'm at somebody's computer here at this, and I need to take a look at this switch, but I don't want to drive over there to the other building. You know, I'd sure like to remotely access that switch. Let's do that. Telnet 10.91.0.5. Password Cisco. I'm in that switch. I'm in this switch right here. Okay, if I enable class, show run, you'll see its switch virtual interface here. Let me go through all this. There's its switch virtual interface, 10.91.0.5. That's what I telnet it into. That, along with this, allows me to telnet into it, remotely access it. Hey, our ISP, I have 8888. I wonder if I can, first of all, let me exit out of this. Because right now I'm in another switch. There we go. I'm back at the regular prompt here on this PC over there. Can I ping 8888? So that's up here, somewhere in the world of the ISP. That's actually one of the Google's public DNS addresses. We're good. We are doing it. You did it. All right. I know there's a lot going on here. I know there's a lot happening here. Okay. Do yourself a favor. Take a moment. Study this diagram. Okay. I'm going to talk about a couple more things here in a moment. But study this diagram. Okay, look at the configurations. Don't look at everything at once. Start small. Look at this access switch. Look at this access switch. Look at what you configured. Okay, regular access ports, trunk link, the switch virtual interface just for remote management. Just like I could remotely access this switch from here as well. Just like we did remotely access this switch from here. We trunk link here. This is our router. Multi-layer switch acting as a router. Okay. It has 3 switch virtual interfaces to be the default gateways for devices in this VLAN, this network, devices in this VLAN, this network, and devices in our management VLAN, that 10.90 network. It's routing OSPF as well. That's how these devices now know about these networks. Okay, just like we can ping and access devices over here, of course, they can ping us. Packets are traveling both ways now. Now, a couple of just last things you can think about. What's on here? What if we wanted to add network address translation? We could add that right here. Okay. I show how to do this in other topics, other classes, maybe this class, depending on which one you're in. But you can configure NAT on this router to translate this 10 dot whatever network address to a public IP address going out and back into the proper private IP address coming back in. We could also create a DMZ here. Okay, this is where we could have an additional firewall. We could have our public facing devices like our web server. We could configure more firewall stuff here. We could configure an additional firewall. And there's different ways you can do this, different design techniques, where you put the firewall, where you put your DMZ, but I won't go into that. We talked maybe about, depending on what class you're in, first hop redundancy protocols. Why not have a second router here, a third router, a fourth? Run HSRP, all connected to a common Ethernet switch, layer 2 switch, and that connected to the core. But then having multiple, in case one router goes out, if our primary router goes down, we have other backup routers, standbys. Okay? Of course, that's additional configurations that we need to do elsewhere. How about some redundancy? How about a second core multi-layer switch in case this one or this link goes down? Maybe we could have 2 or 4 core switches in here with everything interconnected. These are all just independent networks. All right, so we could have multiple cores. We could have multiple, these are what we call distribution switches. Okay, so we could actually have the access switches connected to more than one of them for redundancy. This is later classes. I talk about this a little bit when I talk about switching, VLANs, and multi-layer switching as well. We could even think about replacing these layer 2 switches with multi-layer switches. Get rid of the trunk links here and just do routing from here above. So many good topics. So many ways to take this. This is why every network is a little different. Okay. Most of the time, the network is the way that whoever was there before you designed it, implemented it. Okay. And some of this has to do with, what they wanted to do at the time, the money they had at the time, the devices they had at the time. And if it worked, it works. But sometimes there's better ways to do things. And yeah, so a lot of different options. I hope you found this valuable. I know this is one of the topics I really enjoy talking about. It opens up a lot of things. I know it looks confusing, but again, look at it as individual parts. Okay, and then you put these parts all fit together and then form the product, in this case, the network, as we see here. Right? All right, have a great day, everybody.